So, do you remember the time about 4.1 to 3.5 billion years ago? Mars was just teeming with life. Liquid water, oceans, lakes, rivers, ice, that was flowing around the world. And eventually, but something really had to happen, and you get these really good geological features on Mars that shaped due to the presence of liquid water. And remember the time when it used to have proto-life? We understanding what really happened to Mars. So welcome to Mars Week, Day 1. Happy Monday. So this is from the channel called Cosmo Knowledge, and this was posted about 3 years ago, 88,000 views. So I'm going to give this video attention. So the original link will be in the description down below to kind of give this channel some love. And so yeah, let's get started talking about what early Mars was like and what really happened. Let's get started.
Would you believe me if I told you that Mars was once very similar to Earth? Perhaps there was once life on Mars, but currently this is not the case. Over the decades, it has evolved and is now a totally different planet from our home. It is possible that Mars wasn't always the dry, cold, barren wasteland it is now. Some scientists paint a picture of the red.
Similar to Venus. So if you look at Venus about 4 billion years ago, it wasn't always a planet that was scorching. It was like 900 degrees. It wasn't always the hottest planet in our solar system. But something had to happen in its early life where all that water was stripped. The atmosphere on Mars was stripped. Venus had so much atmosphere, it trapped so much heat, causing a runaway greenhouse effect. Something happened to Mars's magnetic field. It had something to do with, the changes of its habitable zone. How eventually it shifted from one way or another, eventually where Earth is now. And how did all of this happen? What happened to all the proto-life that was on Mars, and what happened to the proto-life that was on Venus? It wasn't. Those two planets weren't always the way that they are today. Something did have to happen. So let's get started.
Planet is having a shallow sea covering much of its surface, making it look more like our own planet. The red planet is a dead planet, but it wasn't always that way. According to rovers and satellites, the dry Martian plains originally flowed with rivers, which pooled into vast lakes and possibly fed into a global ocean. Ancient Mars, like Earth, may have provided a comfortable climate for any emerging microbes. After billions of years, Earth has remained a blue marble, whereas Mars has devolved into a desiccated husk of its former self. While most of the desiccation was caused by the catastrophic loss of Mars's atmosphere, the planet managed to retain
the rapid cooling of the Martian core.
some of its water. Even that small supply, though, is dwindling. Mars's atmosphere may have had a different composition back then, and it was likely thick enough to support a liquid water ocean. So, how did Mars get to where it is now? Researchers have discovered that water molecules are slipping through a protective atmospheric barrier considerably more easily than predicted after repeatedly skimming the highest reaches of the Martian atmosphere with an orbiting probe. When the solar system was still young, baby Mars probably looked a lot like baby Earth. Both planets had electrically charged molten metal cores. The liquid currents swirled through the metals, forming magnetic barriers around the planets. During the Sun's turbulent youth, these magnetic fields repelled both solar wind and electrical assaults from periodic flares, shielding planets' emerging atmospheres. Also, water poured down on both surfaces as thick layers of air enveloped them. On the other hand, Mars was far too small to have a realistic chance of remaining habitable in the long run.
Mars is about half the size of Earth, so that means the gravity is a lot weaker than it is here on Earth. So if you jump on Mars, you jump much, much higher than it is compared to Earth. And yeah, so pretty much with all its weak gravity, it didn't really remain to all that water it had on its surface. The water can only flow a certain way, the water can pool a certain way on Mars, and that's why also penetrated, and that's why Mars kind of lost all its water very early on, because Mars's gravity and its size could not maintain the water that was pooling. So, well, where did all that water have to go to? Well, as Mars' magnetic field and its atmosphere was getting stripped, all that material, all that water was just flowing back into space. So because Mars couldn't maintain all its water, so it just evaporated into the leftover atmosphere that was getting stripped away.
Run. It cooled down more quickly than planet Earth. The core solidified. The magnetic barrier that had been protecting the atmosphere broke down. The sun also blew most of the atmosphere away. Most of the liquid water on the surface of the planet quickly followed it into space. The Mars atmosphere and volatile evolution MAVEN satellite, which has orbited the red planet since 2014, has been tasked with restructuring this 3 billion year history. According to a study released in 2016, researchers found a hint that Mars's ancient atmosphere may have been rich with oxygen, manganese oxide. Because this compound occurs in...
And I think that's what also happened with Earth, because it had the great ironization, where you had remnants of just like iron fillings that eventually formed into the, got into the oceans, turned the planet into a rusty world, and eventually Earth quickly recovered from that. And Mars, on the other hand, it did have the similar phases where it had all this iron deposits. And here's what happens with iron, water, and oxygen. They create this chemical reaction where eventually the water around it, the iron and then oxygen, turns it into all this metal that was left over, turns it into rust. Eventually it grew rust, and eventually just covers the entire planet in this layer of rust.
Wet, oxygen-rich settings on Earth, the researchers believe that liquid water and an oxygen-rich atmosphere played an important role in forming these deposits.
Also, the early planets, our early Venus, early Earth, early Mars, were very volcanically active. So these volcanoes were spewing a lot more carbon dioxide, but also it may contain iron and other metals that were pumping into the atmosphere as well. And eventually, go through the whole cycles. All these deposits float around the planets, into their atmosphere, and then eventually you have raining iron that were collecting onto the ground, eventually causing that chemical reaction when you have water and oxygen.
Another team of scientists observed strange ripples in the sand on Mars. These ripples were unlike anything seen on Earth, and they appear to be unique to Mars. But what can ripples say about an ancient atmosphere? According to the scientists' findings, a thin atmosphere altered the way winds moved through the sand, resulting in these distant characteristics. These characteristics have been fossilized in rocks dating back 3.7 billion years. As a result, these ripples could be used to determine when Mars's atmosphere might have significantly reduced. But where has that atmosphere vanished to? Because Mars is smaller than Earth, holding on to its protective blanket was likely more challenging. Mars's atmosphere was probably stripped away by radiation from the sun due to a lack of a strong enough gravitational pull to keep it attached to the planet. MAVEN spacecraft is currently orbiting Mars and is studying changes in the planet's atmosphere, particularly its solar activity variations. The researchers are interested in learning more about how solar flares, radiation, and coronal mass ejections, CMEs, interact with Mars's atmosphere. The Sun, on the other hand, hasn't been cooperating. While the Martian boundary was never meant to be a perfect seal, MAVEN's measurements indicate that it leaks significantly more than expected. According to researchers, seasonal warming, annual regional dust storms, and decadal superstorms have led Mars to lose a lot of water during the previous billion years, enough to cover the planet.
Because the sun was very active in its early years, and eventually the sun's luminosity increases and is still increasing to this day. Eventually we're seeing the effects of what's happening with Earth, and eventually now we're seeing this on Mars as well, because the luminosity increases, and this is what forms how we get active weather systems, how we have active climates. It's all dictated by how the sun is pretty much acting.
Planet in a global ocean 2 feet deep. That's only a fraction of the water Mars has lost over its history, enough to flood the planet in an ocean that is dozens to hundreds of feet deep. But it's the main reason the planet is still drying out. If you like this video, please consider subscribing and click the notification bell so you do not miss any upcoming videos.
So yeah, that was interesting. I already gave them a subscribe. I've been subscribing from them for a while. But yeah, that was very interesting, kind of looking around Mars's past. Where did all the water go? It was eventually just stripped away due to the increasing luminosity of our sun. And eventually Mars's interior was cooling down, lost its magnetic field, and eventually solar winds penetrated, eventually stripping away everything that Mars had. And eventually it also changes in its habitable zone too. The habitable zone kept changing as the sun's luminosity increases. So eventually, let's say if you look at 4.5 billion years from now, the habitable zone will strip from Earth all the way out to where the asteroid belt, or even further on, because of the sun's growing presence and its luminosity is increasing. And that's kind of where you have weather and you have climate and you have features that dictate because of the sun. So that's pretty much, give Cosmo Knowledge a really round of applause for there. Yeah, subscribe to their channel if you guys are interested in kind of seeing the original video without my commentation. And they also make really good space videos. And I've been kind of addicted to them as we started the space channel. But as my obsession with space keeps growing, because I've been obsessed with space for a very, very long time. And starting to do Mars Week, kind of gives my history of, eventually what happened to Mars. Will we ever live on Mars one day? And then eventually having Zorg come on to the channel for Mars Week, talking about potential living on Mars and eventually Mars itself. So yeah, without further ado, I'm going to close out this video. Thank you guys so much for watching, and I'll see you guys in the next video. Make sure you guys subscribe to this channel and subscribe to Cosmo Knowledge, because they make really good videos. So, original link in the description down below. Let's say goodbye. Goodbye, everybody.